Okay, hopefully this will produce a good recording, like maybe at least the second try today. Any questions before we move on? Okay, I think I forgot to sketch my people. Yep. Okay, so we'll sketch an overhead view of a car going around a turn. Let's get our turn of radius r. You can just draw kind of a boxy car, it's like a toy car. And we've established that it needs to accelerate towards the center. It needs to have a net radial force equal to mv squared over r towards the center. Okay, and this is our overhead view. Oh, and let's not forget we have our velocity, constant speed in this case, changing direction perpendicular to the radius. Okay, rounding a curve, a car rounding a curve, an unbanked curve, so we're going to draw the front or rear view, okay, is kept on the track by the combined frictional forces between the tire and the road. Okay, if you watch a car carefully, you'll see this. They turn the corner, the front tires literally, they both pivot and point a different direction. The car engine forcibly turns the wheels, and so now they're rolling in. Okay, it really just turns the front end of the car, okay, around the curve, but the wheels are trying to roll and exert force in because the car turns the wheels and pushes the ground out. Okay, and it has friction between the car and the tire, and so there it goes. Okay, if we sketch like the back view, get rid of this. Yeah, all right. Here we have our flat curve. We'll draw, it's a boxy car. We need to have the force of friction going in, mg down, and our normal force going up. In this case, our normal force can be equal to mg. Okay, and we want to find the limit of what's the maximum velocity, okay, given so what's the case that we cannot make the turn? If we have our coefficient of friction, that's the tires and the road, it's the condition of the road and the tires also. We have our mu, we have our radius, and of course g, and I think that's all we need. Okay, so our radial force must equal mv squared. What's v max? What's the maximum velocity that you can do the turn? mv squared over r, because you're going in a circle, is provided by the friction force, which is going to be mu mg. Okay, just like on our test, the normal force will be mg minus any tension times the sine of theta. Well, there's no tension on the car, it's just sitting there. It's moving under its own power. So we have tension 0, sine theta 0. Okay, look how it doesn't depend on the mass. The mass will divide off both sides. We can get v squared equals mu times g times r. Multiply the r on the other side. Okay, now your radial force has to be less than or equal to your friction force. If it's equal, you're right at the edge. If the force needed to go in this curve is less than the friction force, you don't have any other force. Your tires will slip. Have you ever done that? You try to start too fast. Tires don't have enough friction, and so they slide. So your v squared has to be less than this stuff. So your v max, or the v that you can actually make the curve, is less than or equal to the square root of the friction times gravity times the radius of the curve. Okay, so if you're going too fast, you can't really change gravity, and on the fly, you can't change the friction. You have to get out and change tires or clean the road or something. But you can make the radius bigger. So if you find yourself going too fast, and you start to slip, you can just take the turn more gently. Don't turn so sharp. Go at a larger radius. You'll be okay. Okay, you could rearrange the same formula to calculate like what's the minimum friction that I need to get around a turn at that speed. That's a racing teams have to solve that problem. Okay. Any questions or comments? No, that's probably enough out of me. And that was half of your time. Okay, good.